Hello and welcome to TidyX episode 63. TidyX's screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. And Tidy Explained is on Twitter at Tidy_explained. And we're also on Gmail at tidy.explained@gmail.com. You can like and subscribe on the YouTube channel, drop a comment, question there, or open up a issue on the GitHub repo.
Yes, and please do, because we definitely see them. We appreciate hearing from y'all. And we, I think in the last few weeks, hit 1,000 subscribers officially on our YouTube channel. And we're over 1,000 on our Twitter. So thank you so much. Keep on sharing. We really appreciate it.
Yeah, that's awesome.
Yeah. All right. So episode 63, we're looking around the world.
We got, this is, what is this? Installment 3 of REGEX Expression? Installment 3 of REGEX Expression. So last week, week 1, we kind of went over the REGEX 101, the basics, anchors, and patterns, and things like that. Week 2, which was last week, we began to look at ways of identifying patterns and enumerating them so that we could make kind of like plots and do some analysis. And today we're going to kick that up a notch, and we're going to use some REGEX Lookarounds to try and identify more explicit patterns and again, further enumerate them and turn them into graphs and charts and things like that.
Exactly. All right. So let me share my screen so Patrick can see what we're talking about here, and then we will get this thing going. All right. Yeah. So let me bring my little handy dandy thing over here. All right, regex 201, regex lookarounds. Yeah. So as with last week, there's some setup where we're pulling in data from the Miami Heat Milwaukee Bucks game 2 from the Eastern Conference playoffs earlier this year. So we're just going to kind of zip through that real quick. If you want to look at more detailed information, go to bit.ly/tidyx episode 61. All right, so we're going to load library tidyverse for our data manipulation needs, looper_date for time dealings, rvest for scraping, and patchwork for some later plot funness. Our theme is set to theme light so that we don't have to worry about setting that specific theme. We're going to load in this data set here, or the web page here, which is the play-by-play data from the game, or the website from the game. And then, so this is a slight modification from what we did in episode 61 and what we did last week, where I've now wrapped the scraping that we do inside of a map DFR. So that way, if you remember before, this was pulling from quarter 1, and now I want to be pulling from all the quarters. But we noticed that the pattern that they used for the HTML classes, or I think that's classes with the pound sign there. It was GP-quarter-1 through 4. And so I was lazy. And I'm like, aha, what we can do is we can just loop over quarters 1 through 4 and pull all that information out for us. We can use the same bind calls that we were before, but now we're going to add a mutate to add a column called quarter, and that's going to be a 1 through 4. So it's identical otherwise to what we did before, except now we're going to pull information for all the quarters. So now we have game data. It's now significantly longer. We have 494 rows of data, but the format is the same. Conceptually, it is identical. The only thing that's new is now we have this quarter column to tell us which quarter this data was pulled from. All right. Now we're going to pull out the game scores. Because it's the same format across all of them, it's the same thing that we did before, where we're going to use a sub or a G sub, whichever one feels most comfortable for you, to pull either the number, or to substitute either the number after the dash or before the dash, turn it into, to remove it, and then turn it into a numeric value, and get the score difference by subtracting the two. Sorry, high level, but we've covered this. So now we have a column for the score of the Heat, the score of the Bucks, as well as the score differential. So which team is winning if it's negative, the Bucks are winning. If it's positive, the Heat are winning. And I don't think at any point the Heat were winning.
No, this was a blowout game.
Yeah. Alrighty. Now we're going to get into the time calculation. This is basically the same. Patrick, actually, do you want to take us through this real quick?
Yeah, this is the exact same that we've done in the last 2 weeks. We take our game score data. We are going to do a little bit of an if-else because we have to identify a true or false as to whether or not the colon is in the time column. Because as the time gets down to the end of a quarter, it goes into seconds. So it'll be like 34.6, 34.5, 34.4, et cetera, all the way down to 0. So if there is a colon, we are going to convert the time into seconds using our lubridate functions for minute and second. If there is not a colon, we are just going to accept that time in the format in the seconds format that it is, so that we can get these down to 0. Then we're going to calculate the quarter time as the time left in the quarter. So basically counting, this will be counting up, right? So we're going from 0 up to 12 per quarter. And then we're just going to also do the same thing, but for game time, right? So now we've got 4 quarters. So we're essentially going to do the exact same thing here so that we can see this game on a chart from 0 to 48 from 0 till when it ends. Exact same thing. And then we're going to add this little team call, which is for team colors, which is, when the score differential is less than or equal to 0, we're going to call it for the Bucks. And when it is above 0, which it, as we said, never happened in this game, we're going to call it for the Heat. And that's going to be useful for plotting our scoring worm, which we did last week and we'll use again here. Just below this code is the score worm. We don't need to really go over this. It's going to come into play in the end. I guess the main things here, this is exactly the same. The only kind of addition, I guess the only addition is this X continuous function. So basically it like run everything up through the Y continuous so we can see that.
Sure thing.
Yeah. So this gives us scoring across the game. You can see the game ends at 48. Obviously, ggplot just carries out the x-axis to 50 for us because they're trying to be helpful. We don't want that, though. We want to have the context be relevant to the actual quarters of play. So we're going to hide the x-axis by using scale x continuous. So it's a continuous axis from 0 to 48. And we're going to hide that axis, though. What we're going to do is we're going to set our breaks from 0 to 48, meaning that we want the scale on the x-axis to go from 0 and truncate at 48, and we're going to set those at 12-point slashes. Okay, so basically, right, there you go. So that's basically the start and end of each quarter. And then over top of those breaks, we're going to label each quarter. So the paste 0 is basically saying paste without a separation, the letter Q, and then each of the subsequent numbers, 1, 2, 3, or 4. And then obviously the end game is going to be the last piece there, which is concatenated into this. And so that gives us 1, 2, 3, 4, 5 labels to paste over top of the 1, 2, 3, 4, 5 breaks that we created. If you were to get off in some way, so if you were to do like from 0 to 50 by 12, R is just going to bark an error at you because it's going to say that the labels don't have the same number as the breaks. Actually,
here it ended up working out because it kind of split out. But if we were to do it to like 60, that's when it'll bark at us and be like, what do I do? Or if what we done is I forgot to add end of game,
then you'll also get an error.
I tried to do that it would say the number of breaks is not equal to the number of labels.
Yeah. So whenever you hide an X or a Y continuous axes, just make sure the breaks and labels are exactly the same. So this should work now. We could show a quick look at the scoring worm before we use it later on. And now we have the whole game, and you can see the x-axis is now within the context of the quarter, which is probably a little bit easier for people to interpret and look at rather than, trying to think like, okay, minute number 32, where is that in the game?
Where's that in reference to things? Like what's going
Correct.
on here? So like right here is the beginning of the second half.
Yeah.
Over here, we did not go. This game didn't go to overtime as well. I mean, look at that. So there might have been. This might have to be adjusted for games that do go to overtime. However, that can be dealt with during that case.
Yeah.
We didn't have to deal with that yet. So
pretty cool. Okay.
All right. Oh, there we go.
There we go. So we got our scoring worm all set up, and we'll throw that in later on. Mm-hmm. But right now we're going to get into some regex expressions and having a bit of a look around. So why don't you take us through that?
Yeah, so I wanted to show us how to use lookarounds, but in context of something we'd seen before. So last week we showed 3 different ways that you might pull from the play details which players got subbed in and subbed out using various techniques. I think we used str extract, or no, we didn't use str extract. We used gsub. We used what else did we use? We used several different techniques. I'm totally spacing on which ones.
We used some of the tidyverse ones.
Yes. Here, I guess I could open it, but we showed 3 different techniques showing how to do it. Here I wanted to show how you'd use an str extract using lookarounds. So lookarounds are kind of a weird case in regular expressions where when we talked earlier about using the caret and the $sign to specify very beginning and very end of a string, lookarounds are another way to set your anchor. But this allows you to then set the location of the anchor in a different spot in your string. So that way you can use like the dollar or the dot star, and it'll look up until that value, and then that will be the actual expression that it extracts and keeps. So in this situation here, so let's take a quick peek to remind ourselves of what the format is of the play details. So remember, it was always player name, space, enters game for, space, player that leaves the game. Mm-hmm. And so if I wanted to identify the player that comes in, I want to find anything that goes up to enters game for, but I don't want to include enters game for. And so if I wanted to, I can't use a string extract to do that. Normally, I could do identify this group and then remove this. And so that would not work for string extract, but it'd allow us to identify what we want to keep. But that gets, you have to use more complicated string R functions to do that. What I'm proposing is that we use these anchors to do that. And what this will do is it'll set our end anchor to be enters game for. So this is a positive look behind. And this is saying grab all the characters up to, but not including anything that ends with enters the game for. So this will grab Bryn Forbes space and stop. And so now that it's got that group that it wants to identify, it'll keep that for the string extract and pull out Bryn Forbes. Similarly, for player out, we have this look behind, this positive look behind. And what this is going to do is it's going to set, I always mix up the order. I think this is a positive look ahead, and then identify everything, use everything that's ahead of this. And here, this is a positive look behind, which is set the new anchor and look behind this. And what this is also looking for the enters game for. But now I'm saying I want to grab anything that's after that. And so this might be a little bit more complicated. Like you have to think about this a little bit more than what we showed last week with the G subs. However, this is a little bit more explicit, as well as the way you write regular expressions actually can impact the speed at which they get executed. Because the more complicated of a pattern you have, the more compute it has to do to figure out and search for the pattern that you're using. And so for us, we're running this, all of these run roughly the same amount of time for us in the real world, the way that we experience it. However, if you're working in a production situation where your expression might be called thousands, millions, billions of times, those milliseconds add up real quick, where it may take 50 milliseconds for the other pattern, but the way that this regex is set up, it takes 40 milliseconds. That's 10 milliseconds of difference. If that's called 1,000 times, that's a second. Am I doing my math right? I think so.
Yeah. Mm-hmm.
If it's called, so it just scales up. If it's only called 1,000 times, that's a second difference in the amount of time of compute you're using. So scale that up real quick. 60,000 times is already a minute of duration that it's being called. So it just scales up. And so if for some reason ESPN didn't have this raw, or only had access to the same data that we have, and wanted to show this same plot that we're showing now, they would care about the regular expression they're using to run under the hood. Mm-hmm. Because that will change, that changes costs. That's real money in how long it takes to run over time, especially people are really interested and they start calling it a lot. Mm-hmm. Because they get charged for compute. All right, so now we have the game time that so getting back to what we were talking about. Sorry, I got on a little bit of a box there. We have our game time. We have which player went in, which player went out, and which team performed that swap. And so we'll run that. So now we end up with more or less the same data set that we had before, where we had like 5 minutes in, Bryn Forbes came in for Drew Holiday. 5:28, Dwayne Dedman came in for Bam Adebayo. So we have that cycle now, but we're now going to look at what is the duration or the number of stints that each player had for a game, for this game in particular.
Yep.
So we only have right now the subs, but we need to also know which players started in the game. So what I did is I went and looked at the box score. It lists the starters. I'm assuming those are the ones that started. Otherwise, that'd be a really awkward name. And just created this tribble here where I list the game time. So obviously that's going to be 0 because it's game start. Which players were in for each team, and then the team name where it was. So we have this table of starters, game time, player in, team out. Obviously no players came out because it was the beginning of the game. And then I'm going to bind them together and then arrange by game time, so that way we have a descending a data frame of each substitution that happened across the entire game. And there we go. So in total there were 80 substitutions across the entire game. No, I want n equals 20. There you go. So no substitutions happened until 5 minutes in, and then we started seeing a good chunk of substitutions between Milwaukee and Miami. Mm-hmm. All right, there we go. So now what we want to do is calculate the stints that occur. So how long is a player in? Because right now we only have this player came in at this time, this other player came in this player came in at this time and came out at this time. But we don't have it like lined up where it's like the direct stint. We just have at time this, Giannis went out, somebody else Bryn came in. We don't have Giannis was in from minute 0 to minute 5, then back in from minute 7 to minute 12, then back out. And so what we want to do is we want to calculate the stints, the duration of time in. So we're going to do a quick unique on players in, so that way we have all the players that played in the game. And in total there were 27, 5, 26, 27, 28 players that played in this game, which, wow, that's a lot of players. To me, at least. Now we're going to go over each player. We're going to map across each player and do some data manipulation here. So we're going to take, we'll step through a single player first, and then the logic will flows through the rest of them. So let's pull out set player to be Giannis Takempo. Oh no, I totally messed that up. I'm sorry. I'm not going to try again though. All right, so we're going to take player flow, which is our data set that lists player in, player out, team, game time. We're going to filter it to keep only the cases the player of interest. So in this case, Giannis is listed either as the player in or the player out. So here now we have this data frame where at game time 0, Giannis came in. Then at this game time here, Giannis went out. And then at this game time here, Giannis went back in. And Bryn came back in, or went out. Then so it's kind of a sequential order, but thankfully it also kind of, there aren't cases where Giannis went in and then got listed twice as in. It is alternating back and forth, which is good. We're now going to create this new direction field where we say, did the player come in or did the player come out, based on whether they're listed in player in or player out. So that way we have a single data frame, or a single field for that. And then we're going to add a new column called player, which lists the player, because as you can see here, we don't have a single player for that. So now we're going to run quickly that. So now we have game time, which direction did Giannis come in or out, and then the player's name. We're going to subset to keep only game time, direction, player, and team. And then we're going to pivot wider. So what this is going to do is it's going to create a data frame, a table actually, where it's the player, the team, and 2 lists. This is kind of a weird thing here, but it's now going to be a list of, these are all the times Giannis came in, and then here are all the times Giannis came out. And so what we can do then is call an unnest on it. And this is also assuming that there's pairing between in and out in the length between there, which it kind of has to be unless there's something wrong with the data.
Yeah.
Right? He can't have gone in and then not come out unless it's the end of the game, which does happen. So we have this case here to look for, is the last row and in the column sub out, is that NA? If so, set it to be 48, because that means he never came out at the end of the game. And then we're going to return that data frame here. We also have this piece of logic in here. So if a player went in and never came out of the game, which could happen if a player comes in at minute 47 of the game and never actually came out, we don't have a sub out. So we're going to just add in a column called sub out, and it's going to be a list of NAs. That way we have a value for them coming out, and it's just NAs, and then that triggers this piece here, which will then drop in the 48 for us. And we're all happy and snappy. So now we're going to run that for all the players here. So now we end up with a data frame that is 80 rows, and it lists each player and when they came in and when they came out. So each row is basically a stint of how long they played. And this does assume that, or it doesn't look and split across quarters. So you may see, I think everywhere here, Giannis, but I know there was a player.
Jimmy Butler. Try Jimmy Butler. I think he was one that went across halftime.
Yeah. But yeah, so Jimmy Butler came.
There you go.
He was a starter, played until 10 minutes in, and then was subbed out. Was out for 4 minutes, then played from minute 14 to minute 36 of the game, which, wow, it's a long stint. But as you can see here, obviously there were there was halftime between there, and it doesn't split across that. So that is a fault that I just wanted to make sure got called out here. If we wanted to, we could add some more intelligent data processing where it would look to see if you played across quarters and then add chops between those to really make it more realistic as to the duration, because you're not playing in those halftime, or there's what is it 20 minutes for halftime?
I don't know, 10, maybe 12. But
But the point is,
it's
there's a
not that
rest.
he's, yeah, it's not, yeah, exactly. If you were to, I mean, the minutes that he's playing in the game are still the same. It's just that technically, starting the third quarter, he really has three stints instead of two, is what it is.
Yeah.
Right? He had a stint that went from 14 minutes to 24 minutes, and then there was a halftime, and then he had a stint that it well
Basically played the whole
essentially
third
went
quarter.
went the entire third quarter, yeah, until it was a blowout, right? So
So they were still hopeful they could win.
maybe.
Yeah. But let's we've got this data now. I want to explore it a little bit. Patrick, do you want to take us through this one? The
Yep.
number of substitutions per team player.
Yeah, so we've got the player stints. We just looked at that. And so to visualize this and turn it into something is as easy as just doing a count. Count the player nested within each team. You're just going to literally count the number of stints that each had. So there's Jimmy Butler, for example, there at row 7, who had the two stints, really three. We know that, but that's okay. So we could see the number of stints that each player had. That's obviously because it's a count, it's going to be assigned to a variable called n. So we're just going to put that into our GG plot with a little bit of reordering. So obviously we want to have this look nice. So we're going to have the columns. This is going to be a horizontal column bar, or a bar plot rather. And we want to order this by player based on the highest number of stints all the way down to the lowest. So we're gonna, So we're gonna gplot. There we go. Okay, and then we're at geom call. So we're gonna fill this by team. So obviously red for the Heat, green for the Bucks. The color is going to be defining the outlining of the column. So we're just going to set that at black, and we're going to have some opaqueness to each of the fills. We're going to set wrap by team with the scales set to free Y, so that you have you don't get this weird thing where you have players from the Bucks showing up on the plot for the players for the Heat with no column, and then it just looks really busy and messy. We're going to fill the manually fill the values for the columns. So Milwaukee is going to be dark green, Miami red. We already talked about that. And then we're going to set our X axis continuous from 0 to 10 by 2, just truncating at 10. I don't think anybody had over 10 stints, probably.
I think 6 was the max.
Oh, 6 was max. Okay, so there you go. Our labels are just stuff that we did last week, where we have some, X is going to be substitutions. Subtitle, we got the caption on there. And then our theming is just all the stuff to kind of make it pretty, setting the plot titles and the x-axis titles. And here we get our nice looking number of substitution, number of stints per player. So we can see that Kendrick Nunn, Dwayne Dedman led the number of stints on the Heat with 4. We could also really quickly see that the Bucks tended to play more frequently substitute players in and out. So maybe they played more diverse lineup combinations. That's another thing we can look at here is lineup combinations. They might have played different lineup combinations trying to throw the Heat off their game or find matchups that they liked. But obviously their best player is Giannis, one of the best players in the game. And he actually had the highest number of stints. So, maybe contrary to like a LeBron or maybe like Michael Jordan or Kobe, who would have played, the lion's share of the game and not come off the court very much. It seems like the Bucks, at least in this game, were trying to do some things with Giannis in terms of getting him on and off the court. I don't know if that's typical. I haven't watched enough Bucks games. But
Yep.
Cool.
All right. So now we're also going to look at what is the duration. So how long on average is a player in?
Yeah. Same. Conceptually, it's the same idea, the same plot. The only thing that we have here is to create a new variable called duration. So obviously we have a column that says when you're in and a column that says when you're out. And because they're both numeric, we can apply some simple mathematics here and subtract the out from the in to get a duration of total time. And then we're going to just throw this into a plot. This time, instead of doing it by stint number, we're going to do We're going to order by duration. We're going to set the x-axis to duration. It's all the same type of concepts. I think, yeah.
So Jimmy
that's it.
Butler.
There you go. Jimmy Butler played the mass.
So this is the average stint length.
Oh, sorry, average. Yeah, that's right. Mean duration length.
Yeah. And so Jimmy Butler here, because he played across, I think it's showing the stint length being longer than a quarter.
Yes.
Because he played two stints, one that was from 0 minutes to 10 minutes, and then from 14 minutes to 36 minutes. And so it didn't work out directly, but it still can show, like, he played for a lot of the game.
Yeah.
Jimmy was in there a lot.
Whereas Giannis is middle of the road for their team, which is interesting. His average amount of time was a little over 5 minutes, actually.
Yeah. So he played hard for 5 minutes and they pull him. Play hard for 5 minutes, they pull him.
Correct. So that's pretty cool.
So that maybe that's something to do with stamina. I don't know. Not to question their ability, but maybe like the style of play is super hard, and you can't sustain that for a long duration. So you don't keep them in for a very long time. You pull them, let them rest.
Right.
And that could be with the style of play they do. Alrighty. Right. But now we want to have this like Gantt chart showing when are the different players in and out across the entire game. So we're going to take player stints. Again, we're going to do a quick group by player, and just so that we have the same duration. But this time it's going to be a sum. So this is like the total number of minutes that they played in the game. I'm sorry for using the same variable name to mean two different things. Sorry, Patrick. And listeners. So then we're going to take player and do a factor reorder to make sure that we list each player by the total number of minutes that they played here. Third in ggplot. We're going to have a geom segment. So a segment is different. So we've been using geom call here, right? Which expects just a y and an x. A segment is actually a line. And so what we can do here is we can create a Gantt chart. And if you've never seen a Gantt chart, it's a project management tool for you to list a task that needs to be done and when it needs to be started and when you expect to complete it. And so it allows you to have a very visual representation of the project that you're working on and when things are going to be completed. And it allows for you to go, oh, we're going to be having these 15 different projects running at the same time. That's not really realistic. We need to maybe shift a couple of these off a little bit so that our people that are working on this can't have some breathing room. They're not working 24 hours a day to get all this done. But I figured this would be an interesting way to retool this, because we know when the players are in or out, we can maybe look for patterns in the way that the teams are playing their players. And so what we're going to do is we're going to use a geom segment, which is a way to draw a line. We're going to set the y value to actually be the same, because we want it to be a line across for that one player, but it's going to draw new lines along the x-axis. And so x is going to start at when they get subbed in, and it's going to end when they get subbed out again. And then as the game moves on, it's going to create a new line when they come back in and end when they come out again. And we're going to color by team, and normally the segment is rather small, so we're going to set size to be 4, so it's going to be a thicker line. We're going to facet by team so that you can see the two different teams. We're going to scale by the team or scale color manual. So we're going to set the colors. Milwaukee's going to be dark green again. Miami's going to be red. We're going to use the same scale X continuous that we did in the worm chart, because we want it to match what we did with the worm chart. And then we're going to use, so you see this tidy reorder within, your tidy text reorder within. So this allows us to reorder within the facets as well. It's a really cool tool from TidyText. But in order to use that, because I am doing this on the y-axis, I also need to do the scale y reordered so it shows up properly. We'll add the labels where the title is Miami at Bucks, subtitle, and then no legend because we don't really want it. And so so let's quickly play player Gantt. So this is our Gantt chart for the players. So I think it's a good way to like quickly visualize, and you can pretty quickly see the difference in the way that Milwaukee versus Miami played, where they have these really long blocks of like Jimmy Butler in, Bam Adebayo in. Like they're playing for long durations of time. Meanwhile, in Milwaukee, it's really choppy. They are substituting constantly throughout the entire game. I mean, it's across the same like top 10 or so players.
Yeah, they just keep it's like I haven't watched enough Bucks games, but maybe it's like a strategy where they're just trying to always get fresh legs on the court and run you, run the opponent down. I don't know, you know.
Yeah, but then you can start seeing how these starters here, they got ahead really good in the first quarter here, and then they start kind of playing less and less, and they start them again in the third quarter, and then they start just playing less and less, and they really start getting in there more into the bench, and then right here at the very end, basically for half of Q4 or the fourth quarter, they have the very end of their bench in there.
You see the same pattern for the Heat, for the Heat, because it looks like once you got to quarter four, they pulled their two best players who never came back out. They basically, and you'll see why here in a second. We'll patch this all together. You'll see that for good reason, they took their best players off the court to prevent any risk of injury or fatigue, and just basically chalked this up as a loss and said, we'll get ready to play the next game. So why don't we patchwork in the scoring worm underneath this so that we have all the context in one place?
For sure. Yeah, let's do that now. We're going to quickly edit the theme for player Gantt, which is this plot here, so that we don't have the x-axis text, because the score worm has that, and we want to make sure they share that. And there's probably a more intelligent way to do this, but this is the way we did it, where we do player Gantt plus theme x.text or axis.text.x is element blank, and then we're using patchwork, so you can division means stack one over the other, and then we're going to use plot layout to say we want one column, so we want them to be stacked. There's going to be two rows. The height of one is going to be 3, and the height of the other one is going to be 2. So that's just going to mean that one is going to be 3/5 and one's going to be 2/5 of the height.
One of the reasons for that, I think, is because our Gantt chart is a facet. If we had a Gantt chart for one team stacked on top of the Gantt chart, a separate Gantt chart, I think it'll actually give each of those 1, 1, 1. But because it's a facet, it sees that as a single plot, so everything gets kind of scrunchy.
Exactly. So we wanted to try to make it a little more interesting, or make this. We wanted these to be close to the same size. At least that was my theory. If we really wanted to, I think this would be 2 and this would be 1.
Yeah.
But I think I wanted to show this as well. So this is everything combined together, where we have the score worm down at the very bottom here, and we have the Gantt charts of the player substitutions. And you can see the score worm, the Bucks jump ahead, Q1 are pretty far ahead.
Basically like a 30-point deficit by the start of quarter two, almost 25-point deficit.
And it pretty much stays there.
They could really never turn it around.
And I mean, there was still a lot of the game left after Q1, right? So you don't just pull your best player. You may be down 30 points, but you don't just pull them at the end of quarter one, beginning of quarter two.
Right.
So you let them play, but they never caught back up.
No.
And so beginning of quarter four, they just pull their best players and go, all right, we're gonna give some game time, some experience to the rest of these players over here, and see how we can pattern them together too. And so I think it's just interesting to see the patterns of the players, and like, are there players that are in when other players are out? Like, looked like Tyler Hero and Andre Iguodala come in when Jimmy Butler is out. Yeah. They're basically only in when Jimmy Butler is out.
Yeah. And it looks like Giannis plays very infrequently with Brian Forbes. So you could see it's always green, and then Forbes is like out, and then he comes in and Giannis isn't there, right? White space, and then he goes out and Giannis plays a bunch, and so those two kind of trade.
So it's just they have probably players with compatible or similar skill sets, and so it doesn't make sense to keep them on the field at the same time, or on the court. But I don't know. I thought this was just a fun way to visualize the data, to once again take the play-by-play string information and turn it into usable data and interesting visualizations that can then be used to, maybe glean some more information. Now that we have this information, we could look at the pattern of who's subbing for who all the time, which players are in during the same times most frequently. There's a lot of different analysis you could do with this. But I think the lookarounds are a very powerful tool. You just kind of have to get used to the syntax that is involved with it.
Yeah, sure.
All right. Super cool. Patrick, if you want to come closer to the mic, so you're a little quiet now.
Oh, sorry. I didn't realize I was. I'm getting quieter.
Yeah. Hello.
Really cool. Yeah. Awesome.
All right. So with that, let's call it. Once again, my name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Warden. You can find me on Twitter at OSPPatrick. And both of us are on Twitter at tidy_explained or on Gmail at tidy.explained@gmail.com. Or take out an issue on the GitHub repo. Send us your questions or things that you might like to see or things you're working on or maybe having some issues with. And maybe we can help sort you out. Or subscribe on the YouTube channel, drop comments on there. We do read those and frequently reply and answer, and sometimes those things turn into a show of their own.
Yeah, exactly. Yeah. So just like that, keep on exploring your world. Thank you so much.